So now in the last video, we looked at this circuit. When I apply power, you can hear clicking there. I can turn the trim pot to increase the speed of the clicking and make a buzzing if I so desire. I'm going to cut this off. We're going to do a quick modification, and this could be considered a quick modification video, although I do have a schematic coming up. So we have the trim pot there. It is just a variable resistor. That jumper was coming to one end right there. I yanked the jumper maybe a little too quick, and I'll get rid of this jumper, although I could leave it. It's not going to anything, and I'm going to replace that trim pot with this light dependent resistor once I get to the correct 2 slots. And there you can see I thought I turned power off, but we can do the exact same thing with this light dependent resistor. Now we got you know, less than or not as low of a resistance at this light level, but I can use the flashlight. And actually we got CC. So I mentioned in the last video that if you see CC on there, hope I said that right, then the power supply can't provide as much current as the circuit demands. So you should raise that so that you never see CC if your goal is not to use the power supply to set a current. We want to set a voltage, a constant voltage. And I do have a schematic that I drew together for this circuit. It is the same one that we saw in the last video where I had a trim pot. But here we swapped the trim pot for a light dependent resistor. That's all I had to do on the schematic right there. So I don't make a schematic for all of my modification circuits, but this was an important one. So we have the light dependent resistor right there, and it's there. The capacitor charges when you apply power. It's discharged. Pin 2 sees 0 volts and tells the output to go high, and the capacitor starts charging through these 2 resistances there. If you get enough light on there, it gets, you know, close to 0 volts, maybe like 30 volts or something if it's pretty bright. But the charging is mostly set by 220 at that point, but under most light levels you got more resistance with the light dependent resistor. If you get it completely dark, you're going to get like tens, maybe hundreds of millions of ohms of resistance, and this is almost never going to click. Just be aware of that. So with the trim pot, we were limited at 10,000 ohms of resistance. This can do probably like 10,000 times as many times as that when it comes to resistance. But in any case, charges through 2 of them. Pin 6 sees 2/3 of the supply voltage or more, you know, at the capacitor, and it tells pin 7 to discharge the capacitor and the output to connect to ground right there. So it discharges through that capacitor. Again, if it's really, really dark, it's going to take a long time, but if it's extremely bright, it's going to be, you know, close to instantly. So again, you know, you might be lucky maybe to get this down to 30 ohms with very, very bright. You know, maybe sunlight will get it even lower. But in case, it won't be a short circuit like we could do with the trim pot, and just be aware of that. But since it's 10 microfarad there, a short circuit even probably isn't bad. I think maybe 1,000 microfarad, it's still okay to short it if it's only like 5 volts. But just be aware that you do have a short if this gets 0 ohms of resistance. And again, passive buzzer needs a current change to make a click. So current goes one way right there, and it just makes a click. That's all it's going to do. So there's no point, you know, ever having current keep flowing through it. You might as well put a capacitor there, coupling capacitor. So a capacitor is going to charge, and then current's not going to flow anymore. That's why they don't pass direct current. You know, it just charges the capacitor. That's all direct current does. It doesn't just keep powering a device or something. It stops. And then when the output connects to ground, then it's the capacitor, actually, the stored charge, that creates that second click right there. But that's all you get, you know, a click. And so that is what the 555 timer is doing. It's alternating between high and low, and the capacitor is alternating current through the passive buzzer, and it's clicking. Now there are active buzzers. They look like this, but they should have black epoxy in there, the ones that I see. Both of them are polarized. We got plus up there, minus there. But yeah, if they got black epoxy, you can probably just connect it to the power supply. So the power supply is off. You can connect this to the power supply, this passive buzzer. But now we don't have a capacitor that is limiting current. So when I turn the power on, you're going to see that it turned off. We did hear a click. But an active buzzer, we would have heard buzzing. Maybe it would need even more current. I don't know. But we would have heard just constant buzzing. This wouldn't have turned off. But that is short circuit protection right there. It turns off when it senses a short circuit. And since this is letting current flow freely, once it makes a click, it thinks it's a short circuit. So we'll go over that. But again, I'm using 10 microfarad capacitors. We could extend the clicking with the higher value capacitor there, but we don't really need to because the light dependent resistor gets such high resistance when it gets completely dark. I tried to find a black clip, but I think red will work just fine, and you can easily slide them off like that once you get the jaws open enough, and you have a smaller wire or whatever clip there at the end. Gonna turn this on, and so black would work even better, but there you can see we can really slow it down. Also, I could turn the lamp off right there. So with the black jumper, I think I could do that without turning the lamp off. But yeah, we can get such high resistance, we can get this to completely stop clicking. I'm just going to turn the power off to get it to stop clicking. So be aware of that. With this, we can get such high resistance. It's going to work better than probably any trim pot that you can get going the full range of a buzz versus slow clicking. Also, for more of a buzz, we could go with, because we can get down to 0 ohms of resistance, plus we always have to have that resistance to prevent a short circuit. So we could use a lower value capacitor. Then no matter what, clicking, if this was a 1 microfarad capacitor, whatever clicking we have with the 10 microfarad capacitor would be 10 times faster. That capacitor would charge and discharge 10 times faster. Everything else being equal. Hopefully that makes sense. So when it comes to the output capacitor, I don't know if that's the perfect value, 10 microfarad or something. I may have tried different values. If it's too big, you'll waste too much current. And if you get too small, then it might not pass enough current to get it to click, But looks like 10 microfarad works fine. But you're probably fine with a wide range of capacitors there. So in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.